the information in red. And here the information transformed stress is a function of the theta, and also based upon the given value here. And the three equations pretty much can allow us to solve the problems. And from here you can see those equations are the function of sine and cosine. Basically, this is the transformed stress are the function of the trigonometry equations. So here in the calculation, sometimes we're interested in finding the maximum value. So that means given how much the theta we will find, for example, the maximum value in this direction, the maximum normal stress in this direction, or the maximum normal stress in this direction, or what would be the maximum strain stress? Okay. Why we want to look for in which orientations the maximum stress will occur? The reason why is this materials. That one. Let me show you a picture. I think that one is in our very old one. See if I can find it. Let me say, if you have been playing soccer, you know the boys or the suckers have to wear, unless you are professional, they won't wear shingles, right? Okay, and they're going to protect your bones here because that is easy to kick and then broken or fractured. It doesn't matter about age. And if you will have a chance to look at the X-ray on the fractured or broken of the bones, and actually due to the age, the fractured angle is different. For young people, for young kids, if they be kicked or if they kind of twist their leg and then get the bone fractures, and those fractures will be pretty much in angle, say 45 degrees. And for people, aged people like me, if I would be accident break my bones, then the fracture would be the horizontal, okay? And that is due to the material properties. For young people, the bone is more flexible. They have a lot of the bone wouldn't be so rigid like the aged people. The aged people, they have the porosity there. So basically, for people like me, the bone is more rigid, which means it's more rigid, it's less flexible. So under the same loading case, and for the bone like me, easily the cracking will be, if there were any crack, the cracking will be in the horizontal plane. And compared to the young people, they will go to the angle one. And that is due to we call the failure mode. Okay, the failure mode will be matters about the maximum stress. For the bones like me, my shin stress is the capacity of my bone to take the shin stress loading is less. Okay, and so that means once if they would have any impact, then the weakness of in the bone would be in the shearing direction. Compared to the young people, they would have the less capacity in taking the normal. So which means if they would have any impact, then always in physics or in nature, they always try to find the easiest way to get into the system. So that means for young people, if they would have less capacity taking the normal directions loading, then if they're going to break, then they're going to break in the normal direction. So for this kind of reasons, in terms of our design, the people like to know in which directions the maximum normal stress will be, and in other direction with what is the value of the theta, then the maximum strain stress will be. So that means with those informations, we want to know the maximum value of the normal stress and the maximum value of the strain stress, because that is for the design purpose. If we will be able to confine those maximum values under the allowable stress, then that design will be fine. And that's one piece of information. Then the second one is we want to know in which orientation, if they were going to fail, we want to know which orientation the crack will be. And that is regarding the number information of the theta. So based upon the three pieces of the equations, the follow-up is to calculate the maximum values of the stress, of the maximum value of each stress component. And that one is regarding the contents is we call the principal. Principal stress and principal orientations. The principal orientation is in that orientation the principal stress occurs, and the principal stress basically that means the maximum value of the normal stress and the minimum value of the normal stress. Okay, so that means in terms of the first two equations, later we're going to see what is the formula for this one. The principal orientations is in theta p. In our text, in most of the textbook, using theta p. P means principal. In that specific orientations, that means in the orientations, how to say? When theta equal to theta p, the theta is the value we use in our formula. When the theta equal to theta p, then the principal stresses occur. Or exist. Okay, whatever. Sometimes people call the principal orientations. Sometimes the people will call it's called the principal angles. And sometimes people would say the principal directions. Okay, all the names simply is referred to the angle theta. And also we, for the maximum value of the last equations is simply with no such special names for that one. So we simply is called anyway. And for tau x prime y prime theta, and we say when theta equal to a special value, we call it theta s, and s means the shearing. Okay, when theta equal to some special value theta s, then tau x prime y prime will become maximum. Or minimum. And there's no special names to indicate what is the name for the maximum or minimum shear stress. And there's no special name. We just say the maximum shear stress or the minimum shear stress. Okay. And there's no special name to call the theta s. Okay, and yeah, so that is the one. So now we dealing with in mathematics basically is we're looking for to find the maximum, to find the extreme values of the two functions. And for the two functions, basically in our textbook and the method we are trying is this. We simply take the derivative of the functions respect to theta, and using the calculus technique, for any functions that's a parameter of the theta, if we want to find for the extreme values, we simply set the derivative equal to 0, right? And to find theta p. Okay. And that is a very straightforward way. And for here, we can, let me directly give you the result. Theta p will be equal to 1/2 arctangent tau xy sigma x minus sigma y divided by 2. Okay, so the principal directions for this formula, and again, using this principle here, you can go refer to the textbook. There's a few derivation steps and to come to this one. And once we know the principal directions, then we plug in, therefore, the tau sigma maximum or sigma minimum. The value that means is sigma x, and then we introduce, say, the theta equal to theta p. And this one will be equal to, for example, and the equal to the sigma y prime theta p. Okay, so this one will be equal to this plus r. This one is sigma. And here, r is equal to this value. And I know that many of you right now at this moment, you have a lot of the question mark in your mind, and how come those equations will be like this, and how will be able to why you skip so many details right up the equation like this. You might have a lot of questions at this moment, but simply you just don't know how to ask. And right, so I know probably some of you have this kind of feeling. But here I try to give you the equation. Later I'm going to explain why, okay? And again, everything is based upon your calculus. Okay, here using this one, we're going to find any extreme values of any function. Simply apply this principle. Then we just do the calculation like this. And again, so far to this point, there's a very last physical meanings behind the equations. So I'll try to impose those kind of feelings to you right away now. Here is, you can listen, you don't have to follow, but here I give you the reason. It's about the y. Okay. So now for this one, I'm going to mess up the writings, and if you could follow, you could right now, what I want is, I want to combine the two terms into a single sinusoidal functions. And that one, I'm going to use the equation is this. I'm going to use the equation say cosine alpha plus beta equal to cosine alpha, cosine beta. Here, why not I just use theta? Okay, so cosine alpha, cosine 2 theta minus sine alpha, sine 2 theta. So I'm going to use minus. I use these equations. So compared to this equation to the pure terms here, if I want to make up this term, then very likely you can see if I will be able to make up the terms and this term to corresponding to the coefficient here. Okay, so likely you can see what I want to do is this. With the definition of the R, let me rewrite that function sigma prime theta will be equal to, so why not for convenience, and here let me introduce one more symbol. So this is called the average, and average plus R plus minus R. So here the average by definition is the average of the normal stress. Okay, the R is definition by that. Okay, so with those definitions, this is the average. And plus, okay, and now I want to rearrange the two terms. So here is this. I take the square root of, I take the square sum of this and this. So that would be R by R. Okay, so from here, if you compare this one, then basically this will become average plus R times the whole thing here. So that becomes the cosine. Let me say alpha, and then minus 2 theta. Or, okay, we'll keep this one. Can you allow me to change the order to theta minus alpha? That'll be more convenient. So here in these triangles, this one, if you compare these formulations, basically this term is cosine alpha. This term is sine alpha, right? Okay, so that means here I have utilized the triangle's information is this. If this will be the triangle, and this is the cosine alpha, for example, this is alpha here. Cosine alpha equal to this one, so that means here this side will be equal to R. The bottom will be sigma x minus sigma y divided by 2. And sine alpha equal to this one, so this side will be equal to tau xy. If the triangle will be look like this, then that fits into our purpose here. Okay, so now in here you can see the maximum value here. The tau x prime y prime is a function of this. Tau x prime y prime is a function of cosine. And let me draw the cosine curve. So this is the cosine. Okay, this is the value of the theta. And I don't know where is the y-axis, but that is not important. So let me ask you, by looking at these equations, who can tell me what is the value of what is the maximum value of this? You see the maximum value of cosine equal to 1. Yeah, so the maximum value is average plus R, like we did here. Let me become clear. What is the minimum value? The minimum value of the cosine is -1. So that means the minimum value